Welcome to our lesson on scatter plots today. If you remember on Friday, we had a test over slope and slope-intercept form. So we're starting a new unit, and it is all about scatter plots and what they are and kind of what we can do with them. Okay, so things we're going to concentrate on today. So one, making sure we can create a scatter plot. Two is determine what kind of correlation or association the scatter plot has. And then three, identify if there are any outliers and types of clustering. And the last one is to identify if something is linear or nonlinear association. Okay, so we have 4 topics that we're going to talk about here regarding scatter plots. Okay, so if you guys would have been in class today, I had a way of collecting data for all of my students. Okay, so we had period 2, period 3. I actually used period 4 and saved their data so that way we could talk about it. Okay, so if you look at the top, the right half of the classroom collected 2 different kinds of data. Okay, the first thing that we collected from them was the letters and their first and last name. Okay, so you will see those already filled in. I did that for them. Then I had them take a typing test online, and they recorded how many words per minute that they could type. So you will see their measurements. Now, some people are crossed out because they were taking the test, or some people were absent, so that's why those people are crossed out. Okay, so that was one half of the classroom, the right side of the classroom. We were trying to see, does how fast they type relate whatsoever to the letters in their name? Okay, so we'll talk about that here in just a second. The left side of the classroom had a little bit different data because we wanted 2 different scatter plots. There are 2 sets of data. The first one is their penalty. So I gave some of them penalties. In other words, they had to wait so many seconds before they could start their typing test. So like Lydia here had to wait 10 seconds before she could start testing, versus Mackenzie had to wait 30 seconds before she could start her typing test. And so we were trying to see if their penalty, how many seconds penalty they had, if it affected how fast they could type. Okay, so if we are about ready to make a scatter plot. First off, let's talk about what a scatter plot is before we make it. All right, but a scatter plot is basically that. It's a bunch of points just scattered all over the graph. And the one thing that kind of makes it unique to all the other different kinds of graphs that you've done, like you've done a bar graph in science or a line graph, usually you're collecting one kind of data. Here we have 2 sets of data. There were 2 things that we had to collect, whether it was the penalty in seconds or if it was the letters in their name, and then also the words per minute that they typed. Okay, also in science class, you guys talked about independent variable, which is the x-axis. So this is the independent variable versus the dependent, which is the y-axis. And kind of today, once we have those 2 things, we're going to see if one actually depends on the other one. All right, so we are going to now graph our information that I showed you earlier. I'm going to erase what I already had up there. So I'm going to make a point for each person that we took measurements from. So I'm going to start on the no penalty side. So at the bottom is the letters that are in their name. That's your x-axis. And our y-axis is their typing speed. Okay, so I'm going to start with Jordan. So Jordan typed, well, first off, he had 15 letters in his name, and he typed 36 words per minute. Okay, so if I make that point, I find 15 letters in his name and 36 words per minute. Okay, so that point right there represents Jordan. And I'm going to go through point at a time. So Camille was 14 and 31. So 14 letters in her name and 31 words per minute. Okay, so that point represents Camille. All right, we're going to keep going on. Connor was 12 and 30. So again, I'm going to go over here. I'm going to find 12 letters, and 30 was his words per minute. Okay, next one is Landon. Landon was 1248. So find 12 across the bottom. So 5, 10, 11, 12, and 48. Need to go up just a little bit. Would be right there. And I'm going to keep going down the list. Francesca was 1848. So 48 was here. 5, 10, 15, 16, 17, 18. So Francesca would be right there. I'm going to do a yellow point here for an 8. So 1135. So 11 letters and 35 words per minute. I'll do gray for our next one, which was Camilla, 1555. There's 55. I'm going to count across by 5. So 5, 10, 15. There was Camilla. All right, and then I'm going to go to Rose. Rose was 946. So 46 is all the way up here. And if I go 5, 10, one less than that, that should have been Lucas there. And the next one is Ashton, 1322. So write 13 and up to 22. That was Ashton. And almost done here. Got one last one. Evan was 10 and 56. All right, so 56 is right there, and 10 would be right there. Okay, so once you create a scatter plot, people will study their scatter plots to see if there is any kind of relationship. Did we notice any kind of trend or pattern in our scatter plot? And if you look at this, it kind of just looks like a bunch of dots randomly across the page. And so in class we talked about, well, does the number of letters in your name affect how fast you can type? If you have more letters, can you type faster? Or do you type slower? Or does it not even matter? And so a lot of the students agreed that it doesn't matter. Your typing speed is not affected by the number of letters in your name. And so later on in the lesson, we'll talk about this, but this is called no correlation. Or sometimes it'll be called no association. Go ahead and pause the screen now and see if you can do another scatter plot, but this time for the penalty side. So I am going to show you all the people there so you can create your scatter plot. But go ahead and pause the screen now, and I will also put up the answer so you can check in the end and you don't have to see me go through kind of question by question. All right, if you graphed your scatter plot correctly, this is what it should have looked like. Now, ideally, when I am collecting data, I wouldn't just collect it from like 10 people or so. We would try to do more and more. The more people I do, the more accurate our data is going to be. So I'm trying to see if there's any kind of relationship between the penalty time and their typing speed. So think about it. If somebody has a bigger penalty, what would you expect to happen to their typing speed? If they have to wait longer, you would expect that their words per minute would be smaller because they have less time. Okay, so what we're going to talk about here in just a little bit is that is called a negative correlation or sometimes association. But basically, as one goes up, the other one's going down. If I fit a line to this, and it's hard to see this, but it should be starting high and kind of going low here, which most of our points fit that data perfectly. There are a few points that do not. They're kind of on the outskirts or on the outside. We will talk about what that's called, but in a little bit you'll find that that is called an outlier. So I would say that these points here, the ones I pointed to, would be kind of 3 outliers that don't match our data. And outliers can occur for various reasons. Maybe somebody is exceptionally good at something, or sometimes they just never learned it before. And so there's always going to be people or things that throw off our data a little bit. And so sometimes we'll ignore those and just look at kind of the average data. But that would be kind of, it would be a negative association. So as our penalty increased, our words per minute should have decreased. Okay, so let's talk about those different kinds of data or different kinds of association. Okay, so we study these scatter plots, and we try to see what is the trend or what is the pattern in the data, because eventually later on this week we want to be able to use these trends or patterns to predict what could possibly happen in the future. Okay, so this association or correlation describes that trend in the data, and there are 3 types. So the first one is positive. Now this is what a positive scatter plot would look like. It looks like a positive sloped line, but it's a scatter plot, so it starts low and it goes high. Now there could still be some outliers or points that throw it off, but that still wouldn't change it. That would still be a positive correlation. And then we have negative. That's going to start high and go low. That would be an example. And then we have none. That on a graph would almost look like it's snowing. There is no rhyme or reason. It's just random. Okay, so for something to be a positive correlation, it says as one set of data increases, so does the other one. They are doing the exact same thing. If one goes up, the other one goes up. If one goes down, the other one goes down. Whereas negative, if one increases, the other one decreases. They're doing the opposite. One goes up, the other one goes down. One goes down, the other one goes up. And none, like we said earlier, they have nothing to do with each other. There's no pattern, no rhyme or reason. All right, so then in class, we came up with some examples of what positive correlation look like. And I'm just going to mention some of the ones that my students or I came up with. So let's say since it's snowing outside, so as the snow increases, we could say the amount of people falling would also increase. Now, don't be like my one class and think people were falling from the sky. I just mean people slipping and falling on that one. So as snow increases, the amount of people falling would also increase. We could also say as temperature increases, oops, did not mean to erase that. Maybe your amount of sweat would also increase. Again, they have to be doing the same thing. So maybe they're not both going up. Maybe they're both going down. So let's say the food you eat. So as you eat less food, your weight would also go down. So less food you eat, the less you should weigh. Okay, so there are some examples of positive correlation. Either they're both going up or they're both going down. Now negative, we're going to have them going opposite. So as one goes up, one goes down. I'm going to start with the one we did in class. So that was the penalty. So the seconds that they had as a penalty. As their penalty increased, their words per minute should have decreased. We talked about waiting in line. So as the time spent waiting in line increases, somebody in class said that your patience decreases. I thought that was a really good one. And maybe we start opposite this time. Maybe we start with something decreasing. So let's say the temperature, as the temperature decreases, our amount of clothing would increase. We put on more layers. Okay, so all of those would represent negative, going opposite directions. In terms of none, I'm going to start with the one that we did in class. So we had letters and name. And we had the words per minute. Those two things were not related whatsoever to each other. Oh, I can't remember all of them that we talked about in class. They came up with some pretty silly ones. I think one dealt with mustard, so the amount of mustard you use. And maybe your pets how many pets you own. They would have nothing to do with each other. We could also do number of shoes in your closet. And somebody, I think in one class said number of chickens you own. So chickens owned. They probably have nothing to do with each other. And those are examples of what no correlation looks like. Now, as the week goes on, we're going to start studying these different types of correlation, and we're going to be able to use them to get more information. I'm going to be honest, if we're looking at things that have no relationship with each other, that's not going to be very helpful. We do not study those very often. We're going to look at more of the positive and negative correlations and see if we can take it further and use the data we have to possibly predict the future. Okay, so that's kind of our end goal as the week goes on. There are other types of things, associations. So these are the three main ones, but if it's positive or if it's negative, we're going to take it a little bit further. Can I fit a line to it? Is it a linear function? Is it changing by a constant rate of change? Okay, so basically, does it resemble a line? Notice it says resemble. It's not going to be an exact line. So does it resemble a line? So on this one, you can see somebody drew in a line. That data is almost a perfect line. So this is definitely linear. Now the one on the right, it started off being perfectly linear. I mean, that was spot on right there. But then at the top, it took a turn and it went back down. So that one was nonlinear. It started changing directions on us. And that's kind of the difference between linear and nonlinear. Again, as the week goes on, we're not going to be studying nonlinear functions. That's algebra 2 when you get more into the nonlinear. We're going to be looking at the linear ones because that's what our last test was over. And we know how to use, well, we know how to write the equations of the lines and how to use that to help us answer some more questions. All right, and the last little bit. If you remember when we originally graphed our scatter plot, we had some people that were on the outside or that didn't match our data, and we called those outliers. Okay, so going back to that, we have an outlier here. The formal definition is a point that doesn't seem to fit the pattern of the other data. So you can notice this guy does not seem to match the pattern. So that would be an outlier. Now in class we talked about, well, what if I drew a face up here, and I'm not going to make it smiley or frowny, I'm going to make it a neutral face, if that one would be an outlier. And so we kind of had a little discussion on that. Some people said yes, some people said no, and the answer ends up being that it is not an outlier. And the reason behind it is it has to fit the pattern. So if I keep the pattern going, that point eventually would be on our line. Okay, so this is not an outlier. It matches the data, but this one right here, the guy with the headphones, the smiley face, definitely would be an outlier. And over here as well, this point was the one that does not fit the other data. The other data was starting high and going low, and that guy threw it off. All right, and that is it for the notes. There is a homework assignment. I have attached the answer key if you need some extra help. Also, don't hesitate to reach out to me. All right, hope to see everyone soon. Bye.